Tom, thank you for this interview today. You've recently expanded on your explanation of physics from your My Big Toe. Could you comment on your presentation of the double slit experiment and how you further clarified the current information? The current information out there is the observer collapses the wave simply by observing. And I know you've taken this explanation a little further to try to get people to, and scientists maybe especially, to try to further clarify a very difficult concept to grasp. Could you expand on that?
Sure. You hear often that in the double slit experiment that the particle, you collapse the wave to a particle, right? It starts as a wave function, a probability wave, and then that collapses to a particle. And sloppy language will say it collapses to a particle because of a measurement, and that's what's referred to as the measurement problem in physics. So you hear it said that it collapses to a particle because of consciousness, a conscious observation. Well, these are similar. Conscious observation is required to make a measurement, so you can see how one might do that. But the fact is that both of those are really not accurate. It collapses to a particle because information is gathered on which slit the particle goes through, and that information is made available in this physical reality frame. The information now is available. So it's not a matter of consciousness being there and making an observation, which of course is required, but it's not a matter of just making the measurement. That's required too, but it's not just that. It's that the measurement of which slit it goes through is taken and made available in the reality frame that we're in. So it's a matter of information. The information's gathered and made available. Now, why is that the key? That's the key because the whole reason that the double slit experiment works the way it does is that there's a couple of rules that say how this virtual reality works. They say that the virtual reality must remain consistent. You can't have just things changing in the middle of it. That would make a very squirrely, we call funhouse reality, right? It wouldn't be the kind of reality we need for feedback, for learning, for growing. It would be ineffective. So you have to have a consistent history, and you have to always abide by the rule set. Okay, so what would happen if you measured a particle? Then it would be inconsistent. If you say a particle went through the slit, it would be inconsistent then to not have a particle make one spot right on the screen right behind that slit. Once you say there's a particle there, then it has to act like a particle and make a spot, you see? So that's consistency. Okay. But we have, so we have that situation. You can't say there's a particle and oh, guess what? That particle produced this diffraction pattern. That's all the little spots. That wouldn't make sense, right? That's an inconsistency. So once we collect the information that it's a particle and a particle went through the slit, then there's no other, there's no other possibility other than we get the one spot of light behind the slit of a particle. Okay, so it's not just that we make a measurement, and the reason that there's a difference here is that in quantum theory we have a process called erasure. You see, you can take the data. All right, now you've made the measurement. The consciousness has made the measurement and taken the data, but before anybody looks at the results, they erase the data. Well, when that happens, you get the diffraction pattern. You get the array of spread out lights. Well, the measurement's been made. The consciousness was there, but you still get the diffraction pattern. Why? Because the data, the information, is not in this reality frame. There's nothing in this reality frame that says a particle went through any slit. Well, we had that data, but we erased it. We don't have it anymore. So it's not inconsistent, you see, for us to get a diffraction pattern. You can't say, well, there was no particle, or we don't know of any particle, but here's where the particle hit. You see, it's like you don't have a particle, but here's where it hit. That's inconsistent. So now you have to get a diffraction pattern. So if you know it's a particle, it looks like a particle. If you don't know, then it doesn't. And it doesn't matter whether you collected the data and then erased it, or whether you just didn't collect it. You see, that's all the same. And that's a very key point, because that tells you that what's important here is information. It's not really the measurement, it's not really the consciousness, it's the information that is important. This reality is based on information. In a virtual reality, you have to have rules that say your virtual reality is consistent. So it's the consistency rule and the fact that this is information that makes it work that way. And otherwise, you see, the eraser experiments would never work. You wouldn't take the measurement, right? You'd measure it. You'd have the data. Okay, the measurement is going to measure the particle, although we don't know that because we haven't actually seen the measurement. But we assume the measurement is measuring what goes through the slits. But without looking at the data on the screen or our measurement data, either one, we then erase it. Okay, see, that's the idea. So because you erase the data, it actually then gives you a diffraction pattern. Don't erase the data, you get the two spots. The only reason that happens is because it's a virtual reality has consistency criteria. You see how that's the key to it. I don't know if I'm making it real clear or not, but that's the key to it. Because if you didn't have a virtual reality, and it wasn't just a consistency requirement, it wasn't the information, then the erasure wouldn't make any difference. If it was just, did you do the measurement, then okay, we did measurements. The detectors were working, you know, the electrons were coming through the slits, the detectors were working, we made the measurement. Now it wouldn't matter whether you erased it or not. Whether you erased it or not, you'd always get the two spots because you made the measurement. You see, but it's not just a measurement. So once we do those erasure experiments, that's what tells us this is a virtual reality and its information is the key, and it's a consistency requirement. So that's why the double slit works the way it works. That's the fundamental issue that's going on there.
Everyone is searching. Physicists are searching for the grand unified theory. What key elements are missing in their search for the grand unified theory? Some have put out a little bit of what they see as a grand unified theory. What is missing from their big picture that you have in My Big Toe?
Okay. Well, there's toes and then there's big toes. Now, most of the science people, most of the physicists who would claim that they are, you know, most of the academic physicists working on theory. You know, if you're not an academic physicist, you're generally not working on theory. You're just applying science, and for the most part, you're applying Newtonian physics because that's the area where most of the physics is applied. So you're just doing applications. The universities is where theory work tends to be done, and physicists that are in universities are probably only looking for a little toe. They probably would tell you that a big toe doesn't exist, there is no such thing, it's impossible, it couldn't happen. So they're really trying to come up with an overarching theory that explains quantum mechanics and relativity, because those two theories are both very successful theories. They explain, or they predict the results, and then the experiment verifies that those results actually do indeed happen. But they are fundamentally at odds with each other. Each one denies a tenet that the other requires. So we know that they're not fundamental. There's something else there. If each one says that the other one is based on a false premise, but both of them work, but they don't work in general, each one works in its own little area. So you have quantum mechanics and it works in this area, and then you have relativity and it works in this area. Each have an assumption that the other one denies is true. So it's obvious that there's something else, something bigger that, you know, both of these can be derived from, and then you derive this one based on this assumption, and it works in this area, and then you make another assumption that's different for this area, but they're not fundamental science. So that was the idea that led Einstein and others to search for a toe. But now this is what I call a little toe, because it's just about one understanding that explains science. And this is a very physics-centric view. So we say explains physics, and that physics is the root of science. Engineering is applied physics, and biology is applied physics, because it all starts with particles and everything else is built up out of the particles. So, physics then is at the root of reality. So, pardon my provinciality, but when I say physics, I'm talking about science in general. That's a physicist's view of the rest of science. The biologists probably wouldn't like that, but anyway. So that's a little tau. Now, I talk about a big tau. So what a big tau is, it has to do that. It has to do everything a little tau does. It has to come up with a better science that can derive both relativity and quantum mechanics. Okay, so the little tau is a subset of the big tau. But besides that, the big tau has to be able to logically derive not only objective reality, but subjective reality. It has to explain consciousness. It has to explain the paranormal as well as the normal. It has to derive metaphysics as well as physics. It has to derive the fundamentals of theology even. Why are we here? What are we doing? Is there really a larger source someplace? And if so, how do we relate to it? Where did it come from? What is it? So these are like theology questions. Now, a big tau has to answer all of those questions. It's not like those questions aren't important. Those are important questions, and a complete science should address those questions, as well as, how fast does this ball fall when it's dropped, from a tower? That's a smaller set of questions. So a big tau now explains it all. So what's missing? What's missing from the little tau? Obviously, they have failed at a little tau. We have string theory that's attempted a little tau. We've had a few other things like that have attempted little tau. Actually, if you look at what Brian Whitworth is doing, he's really only working on a little tau. He's not trying to do the big tau. The many worlds theory, that's just a little tau. They're just trying to describe physical reality, because in their minds, that's all there is. You see, there isn't anything other than physical reality, so why would they try to describe anything more than physical reality? That's it. So all those ideas are really just little taus. And so far, science has failed. Einstein failed, and everybody else has failed to really come up with a little tau. The reason that they have failed to come up with a little tau is that the answer to how do you derive both quantum mechanics and relativity, how do you do that, can't be done from the physical, it's not something that can be done from the physical reality assumptions, which is where they're starting. The overarching understanding has to take place outside of the physical reality. The overarching understanding is bigger than that, and we're led to that in science many places. One of them is the Big Bang theory. Okay, physicists say that our universe started in a Big Bang, and what they mean by that's a metaphor for at one time our whole universe was just a very small ball or point, if you will, of very high pressure, high energy, high temperature energy, right? Just all in a wad. And then the metaphor, bang, it was let loose. And when it was let loose, then it expanded, it cooled, it produced this universe, it produced all the planets, it produced the Earth and the Sun, and it produced us. We all evolved then out of the universe after that. But there's this problem. Well, what was holding it all together? What let it loose? Where did it come from? Where did it start? So, of course, there's no answers to that. Those are unanswerable questions in physics. The reason they're unanswerable is, well, wherever it started, whatever was holding it wasn't part of this universe, wasn't part of this physical reality, because this physical reality didn't exist yet. It didn't exist until that thing did bang and expand and cool and coalesce. Then you got this universe. So physical reality was all contained inside that little ball, if you will, the potential for it. It hadn't been let loose yet, but that was it. But what was what was the outside thing holding it together? Where did that come from? Where did the little ball of energy start? You see, it had to start from somewhere other than what was inside the ball. You're talking about constraints on the ball, have to be outside the ball. It didn't constrain itself. And then suddenly, bang, you see, and where did it come from? So the answers to those questions are it had to come from what Friedkin said is other. It came from other. And that's as far as he could get with it. Well, if you can't figure out where other is, and if you don't understand other, then you can't get an answer to a toe, because that's where it all starts. You have to back up one more level of causality, if you will. You can't get it out of this physical universe, because the causes that we're talking about that allow you to derive relativity and quantum mechanics and understand them, you have to take to the next level of causality, which from this universe we would call from the non-physical. Now that's just making a definition of this universe is physical and everything that's outside of this physical universe is non-physical. Well, at least it's non-physical to us, isn't it? So we'll just call that non-physical, being non-physical to us. So that's where you have to go with your understanding as to how these things work. Where did the Big Bang come from? How is it that our universe is expanding in an accelerated way? You know, our universe is accelerating. The outer edge is accelerating outward. It's expanding at an ever greater rate. What's it expanding into? What is outside of our universe that allows our universe to expand into it? So that's an unanswerable question. But it's not even a good question. It's a question based on an assumption of an objective causality. An objective causality, if something expands, well, it has to have something to expand into. But if that something is beyond our universe, it's not physical, it's not a part of our universe, so what's going on here? See, so physicists paint themselves into logical corners that they can't get out of, and they don't have any answers because their assumption's wrong. Their assumption is that this is a physical, objective causality controlled universe. And it's not. This is a virtual reality. That other that Friedkin defined is consciousness. So instead of trying to start with the physical reality, how can I derive from this physical subset where these, the step above this quantum mechanics and relativity, it won't work. You have to get to the next step up. So you have to start with consciousness. And from consciousness, you can then derive quantum mechanics and relativity. Now, Einstein and Wigner and Heisenberg, Bohr, all of the kind of the big guns, the big thinkers, the big brains in physics back in the 20s, early and mid-20s, they kind of had that idea. You've read some of the quotes that I've had, and basically, you have Einstein saying, space isn't anything independent of the mind, right? Well, that's saying consciousness, is what he's. Now he may not thinking that, but his statement is just kind of crying out. That's the answer. If space isn't independent of the mind, then mind must be more fundamental than space. Well, if mind's more fundamental than space, well, he call it mind, but he's talking about consciousness. You have Wigner saying that the reality that the physical world is a product of consciousness. So these people, the big brains of 80 years ago, understood that somehow consciousness was that bigger thing that you had to start with to get here. But they didn't know how. They said, all right, but that's just weird. We don't know what to do with that. The reason they didn't know how to do with it is they were trying to come up with a physical solution. You see, that you have a superset. Here's consciousness. Physical reality is a subset within this superset, within consciousness. Now what they are trying to do is within the subset, they're trying to derive and define the superset. You see, that's logically impossible. You can't define a superset from one of its subsets. It doesn't have the information inside the subset to define a superset. That's how, that's what a subset is. It's only a piece of the larger set. So that was their problem. You say, why can't they do it? It's because they're saying, all right, here we are in this subset. It's called physical matter reality. How can we drive the superset that created the Big Bang, that created all these things, and there we'll find the answer of how to derive quantum mechanics and relativity. Well, you see, it doesn't work. You can't do it that way. So the reason that they don't work is because they don't see a bigger picture beyond the physical reality. So that's the failure of science, to find a toe, a little toe. Now, what about the people working on big toes? Well, there are a few people that say that they have theories of everything. Mostly they're talking about little toes. Their everything is the physical world, because in their mind that is everything. So they don't know that that's only a subset. They think that is everything. Okay. But the few that talk more about consciousness and whatever, they generally fall into a couple of categories. One is the standard scientific approach to consciousness is the brain creates consciousness. So they start again with a physical subset and trying to create consciousness from the physical subset. Doesn't work. Consciousness is not a product of the brain. Those kinds of discussions have never been successful. It's been around, for I don't know, probably 100 years, and it doesn't work. Consciousness is bigger than the brain. It can't be explained that way. So that's a failure. They don't get there because they want to start with consciousness, but they want to start with consciousness derived from physical matter. You see, so that fails. Now the other group comes up with some kind of grand scheme. Reality is a hologram. Reality is a 0-point vacuum field energy that floats everywhere. This kind of thing. So they get these kind of airy ideas that they make up, and then they make assumptions to try to prop up why that might work. There's there's pieces of truth to that. There are attributes of a hologram are seen here. You can kind of see how that might fit, but it just isn't so. It isn't true. A hologram is a device that you have to shine light through to recreate an image. That's what a hologram is. This is not a hologram. Okay, a hologram image, even if we say physical reality is a hologram, well then it's light. This isn't light. This feels physical. Why does it feel physical? Because we have a data stream coming to us that we interpret this as physical. It is physical, where our hand only allowed to come this far, and then it hits something solid that stops it, because that's the data set that we get. That defines that. So they tend to have kind of large-reaching concepts of how the world works, and they need a lot of assumptions to prop those up, and they don't really explain everything, and you can't really derive quantum mechanics or relativity from them, but they do kind of say that, well, if that's true, then maybe that explains why you'd have paranormal, so they might do that, or maybe it would explain why you have, I don't know, whatever, this event. So they try to explain a few things, but they don't ever seem to be coherent. They don't say, well, okay, here we can, given our assumptions, we can logically derive theology, the paranormal, quantum mechanics, what the universe expands into, what happened before the Big Bang, all these big questions. They can't do that. They basically can show that a few things seem to be reasonable, sort of, but it's more of a, look at this, isn't it neat, and don't you see how it kind of fits? And that kind of fits gives them a certain sense of having said or done something important, because it does kind of fit, but it doesn't really fit at the details. It just kind of fits in a general talky hand-waving mode, but when it gets down to, well, why does that derive quantum mechanics? Why does that tell you that particles need to be probability distributions? Oh, well, it doesn't. How does that tell you the speed of light is a constant? How does that tell you why people can have precognitive dreams? Does that derive, theology? Does it derive, what's our purpose? Why are we here? No, it doesn't derive any of those things. So what does it do? Well, it sort of kind of fits, and it does kind of make this seem like it could be possible. It's like watching Down the Rabbit Hole, What the Bleep. If you watch that, there's all kinds of things in there that say, well, and this is kind of neat. And, you know, if you look at this, doesn't it see that maybe that could support this? But it's all airy and it's all questions. There's not, look at this, see how this derives that? There's nobody ever mentions the word derive. It's look at this and don't you see how this possibility might kind of support that idea? It's all questions. So if you look at the rabbit hole, you know, down the rabbit hole, what the bleep, it's all about questions, neat ideas, neat concepts. I see a relationship between this and that. Isn't that neat? But it's not, you know, here are my premises, you know, I can derive logically to get from this to that. None of that's there. So it's all questions. It's no answers. Just hypothetical. Yeah, this could be an answer. We don't quite understand it yet, but I can see that it's maybe leading in that direction. And that's where most of the big toes are. They see kind of bits and pieces of ideas, and it looks like they could sort of lead into an explanation of something or other, but the way is not exactly clear, and it's not quite logical yet, but, you know, there's nothing else out there, so this is promising. So this is the best we have. Let's go with that. You see, that's the attitude for the big toes. So none of them actually can solve any of the big problems, but it's promising, and we're working on it. So you say, you know, why, you know, what are they missing? Basically what they're missing is a theory or a concept that has very few assumptions and just then is a logical derivation to the results. And not only just this result, well, that explains, you know, precognitive dreams, but it doesn't explain quantum mechanics. You see, it's not that. You have to have a few, just a couple of assumptions. Then you have to drive everything. If it's a theory of everything, tell me about subjective reality. Tell me about quantum mechanics and relativity and the Big Bang and the expanding universe and theology and why we're here and what we're here for. And, you know, what's the point and purpose of all of this and where does it come from? And how is this manufactured? You know, if you can't do that, if you can't everything, then your theory's missing. So at least, now this is my, you know, kind of casual opinion of the things. I have not gone out and studied. You know, I need that as a caveat. I haven't gone out and studied a lot of these things. I kind of brush by them. You know, they buzz by on YouTube or something, and you kind of look at it. And without going into it deeply, it's like, well, that's very limited. It's a lot of hand-waving, and it's mostly like down the rabbit hole. This is cool stuff, and I can see that it might apply to something. And the reason it's taken seriously is that people think there's nothing else. So they cling to this. At least it's a promise of something. Maybe someday this will mean something. So it is, you know, it gets popular, and the books are written, and there's groups of people that kind of cling to that hope that that is someday going to explain something. You know, and they do that inside of physics as well as outside, and their little toe. String theory is the same way. You have all kinds of physicists spend their careers on string theory with the hopes that maybe someday it will actually do something significant, something measurable. Probably won't. It's a theory that does explain things, but it's based on lots of assumptions. You know, if you have 14 different dimensions, then you already have started with 14 assumptions, much less whatever assumptions you must add to it. 14 assumptions is too many for something to be fundamental. So the problem with string theory is that it's not real science. It's more, you know, smoke and mirrors. It's a formality. It's a mathematics that if you make enough assumptions, you can make the mathematics tell you something. Well, you can make anything tell you something if you have enough assumptions. So that's the, you know, and there is a lot of people inside the physics community that will say that. Well, they'll say string theory is a bad idea. It's bogus science. You know, it's not really going to take us anyplace because it's not fundamental. Too many assumptions. Same with the, you know, with the many worlds. Now, physicists are out there working on many worlds, but the many worlds theory, again, these are little toes. The many worlds theory has so many assumptions. Every time an electron changes state somewhere, you have to have another universe because now it's different. You see? Well, we get into, you know, numbers so astronomical it doesn't make any sense. What kind of system would waste those kinds of resources? You see, it's not, what do we call it? It's not frugal, it's not parsimonious. Okay, so you have you have to create another universe every time any trivial change takes place. A whole universe, just because some electron, flipped its spin state or something. Okay, theoretically, we can do that, and we can work out, we can explain a few things, but, there's assumptions. What kind of resources are required to, spin off universes in the gazillions of numbers just to mirror a minor change? Because you have to do it for every minor change. You can't say, well, it's only when these minor changes get up to something significant, because then you have to define what's significant and who decides what significant is, you see, so you can't get into that. If it's objective, it has to be every single state that's possible. You need another universe for that state. That is, no, okay, we can do the theory, but it doesn't actually take you anyplace important. It's just it's somebody that's desperate to come up with some kind of an answer that explains this weirdness, you see, that they do. But you have something so much simpler. You can explain the double slit experiment so much more easily by just saying it's information, and we live in a virtual reality. Okay, those are, even if you call those assumptions, we can derive both of those from consciousness. But even if you just start with those, then you've got your answer. You don't need, 10 to the 42nd, worlds, total universes, somewhere in different dimensions of, phase space, or who knows what, You use a lot of big words, and then it sounds important, that it almost sounds credible. So that's part of the problem with, with those kinds of things. They have their own difficulties. But they are bona fide fields of science, and there's probably, 1,000 physicists that work in many worlds and string theory. And they all have careers, and they publish their papers because they can monkey with an assumption, and then they get different results, and then they all can argue about what these results mean, and it's just it goes on. But it's not really a productive science that we have seen in the last 30 years since it's been running. It's never really converged to anything significant. All the breakthroughs are all breakthroughs in how to better calculate it, adding or subtracting, multiple assumptions, that sort of thing, and then seeing what that does to the mix. So they're all breakthroughs in fiddling with the game that's being played. So that's a long answer to big toes, little toes, and why is mine different? Mine starts with two assumptions: consciousness exists. And basically, it's the assumption that consciousness is a self-aware potential originally, a self-aware potential that could differentiate state 1 from state 2. That's it. Okay. Now, where did that come from? I don't know. You have to start with that as an assumption. The other assumption, after that, it just evolved into what it is. The other assumption, then, of course, that evolution exists, and that's so obvious from looking around. And evolution exists means that if you have a large, complex system that changes, say self-changing system, that system will change itself, will modify itself based on some criteria for success, if you will. Physical evolution, that criteria for success was procreation and survival. Okay, in an information system, it's reducing entropy, more content to the information, less randomness. Okay, so that's it. But also, we have all kinds of systems that evolve. Our monetary systems evolve. Our social systems evolve. Our technology evolves. That means it changes. It's in this state, but there's some pressures that move it to a different state. Well, in technology, it's not survival and procreation. It's market, it's demand and technical, you have a technical ability, you have demand and you have cost. Well, if the demand's high and the cost is reasonable, the technology will evolve that way. You see, those are the two pressures that make it go. So here's a lot of demand for this, and oh, hey, we can do that cheaply. Well, that's going to happen. Oh, here's a lot of demand, but it would cost $1 billion to make one. Well, that just doesn't happen. You see, so we've got cost and demand are the criteria for driving the evolution of technology. But technology evolves. Governments evolve. All sorts of things evolve. And they have their own environment of pressures that define how they evolve. So the second assumption basically is that evolution exists. Complex systems that are, that basically change themselves. Technology changes itself in the sense that it's built. Each new technology is built on the old technologies. So we mean it changes itself. It grows from change of the technology. You have this, you have tube technology, and then that goes to, you make an advance, and then you have transistor technology. But you couldn't have gotten transistor technology. You hadn't had tube technology first, and you couldn't have gotten that if you didn't have that first, and you couldn't. So that's why it's an evolutionary process. It's based on the self-changing system.
We can see that in our evolutionary process, as you just described,
Sure.
and it mirrors, you're saying, what happens on a consciousness.
Yeah, a consciousness. Take this energy, this potential energy that can differentiate two states. That's all you need to start with. If it can differentiate two states, then it can differentiate 3 states or 4 states. You just have something that can differentiate one thing from another. Well, now it evolves. It grows. It increases its capacity. It becomes more effective at what it does. Well, so it grows, and these 2 states, of course, become ones and zeros, making that the metaphor there with data. So it becomes ones and zeros. So then you have a state that's growing. It's an information. It's an entity that's basically based on information. It evolves. As it evolves, it wants to lower its entropy. That's how it survives. That's the thing that defines the criteria of how an information system evolves. Higher entropy means more randomness. Lower entropy means more content, more information. So it has to evolve by lowering its entropy. It does that by creating more ones and zeros, more information, more complexity, more organization, within its bits that are available. And so when it grows, the bigger it gets, it has more ways that it can put things together, more patterns of patterns of patterns. Then it gets to a point that says, well, I've got all these patterns and patterns of patterns. What else can I do? How can I evolve further? I need more complexity. I need more ways to define content. Well, a new technology is born. That new technology is called time. Now we have sequences of patterns and sequences of patterns, you see. And what's time? Well, it's just that one of those ones and zeros. 1, 0, 1, 0, 1, 0. That's a metronome. That's a clock ticking. It's time. So time's invented as a way to then, a new technology to create sequence of patterns, of numbers. That gives you a huge explosion in what you can do with these patterns. You now have another whole dimension in which you can change things and modify things.
Speaking of patterns, you introduced in your My Big Toe process fractals. For the math people out there, could you describe a little bit about what you did and how you placed this into My
Sure.
Big Toe and its significance?
Okay, well, a process fractal is very much like a geometric fractal, except it's based on processes instead of geometry. First, a geometric fractal is you take a simple shape. The Mandelbrot set was one of the first, that defined fractals. He took a simple shape, just a little curve, or you could be a little triangle, it could be any kind of, but simple, nothing too complex. And then you would add more to it. So let's say you had a triangle, and then you put a triangle on each side of the triangles. And then you put a triangle on each side of each one of those sides. And you can put bigger triangles, or you can put little triangles. You can maybe put 100 little triangles along that side. And then, they change scale, but they keep just building on themselves. You might even think of evolution, right? They keep building on themselves, adding more and more triangles to this mix. And pretty soon what happens is these designs grow into, some of them are very beautiful, they go into art. And they also found that they start looking like clouds and forests and rocks, and they start looking like natural things. So there was a big study of fractals, geometric fractals, because they're used now in animation. They can create a look of mountains and clouds and sky for a video, and they can do it in seconds with fractals, rather than having to draw it, or rather than having to go out and actually photograph it or anything like that. They can make it so it's very realistic looking, just with fractals in a computer. So they use fractals to represent physical reality. Okay, and that's natural because at the bigger picture, now we're stepping up to the next level of picture beyond physical reality. Consciousness I've described as a process fractal. So what's a process fractal? Process fractals, you take this process, and this is a simple process, and then this process has has like an output, say, and then you take that output and you feed it into the same process, and you take those outputs and you feed it into the same process, and you do the same thing as a geometric shape. You're just building a process fractal. So one process feeds the next process, feeds the next process, feeds the next process, and you build things up with this process. And what happens is you get a fractal pattern, process fractal, different scales, different ways the processes are, the scales that they're worked on, how they, maybe how far they iterate, how many times you go through the process, whether they converge or not. There's different things you can do with a process that you don't do with geometry, but then you end up with a process fractal. And what's the process? Evolution. You see, that's the fundamental process, is evolution. And it's a very simple process. The simple process is that you have something, you have a thing, you have a, I don't know what, I guess you have relationship. You have objects that relate in some way, and then you have this process of evolution. So there is some criteria for their purpose. That's like, the survival or procreation in the physical evolution. Yeah, and they change, they evolve, they change according to, well, is this better? Does this suit our purpose better than before? Oh, it does. Okay. Well, then let's build on that one. And maybe more randomness. Does this? No, it doesn't. That takes us away from our purpose. Forget it. See, that's how evolution works. Things happen. You try things. It's like random process. And sometimes you run into things that work, and sometimes you don't. The things that work, you build on. The things you don't, you let go. So you invest in what works, and you divest the stuff that doesn't work. So that's how your process works, and these processes feed each other. So here's consciousness, and consciousness is this, ability, this information field. Okay, we just defined it a little earlier about consciousness being a digital information field, ones and zeros. So here it is, and it's evolving. As it evolves, what does it do? Well, it recreates its own process, its own substance. And now you have a smaller piece of consciousness. And that smaller piece of consciousness is also evolving. And within that piece of consciousness, it may have something else, and it's still evolving. So see, this is what creates a process fractal. You have all these processes kind of linked together, and you can see how this builds. We see repetition. Just like in the physical world, you see repetition. That's why fractals are so good at doing the real world. You see order. You see the seashells that are all spiraling out according to a mathematical scheme. It's not that sea creatures are good mathematicians. It's that this is just, the fractal process, the mathematical process is a logical process. Mathematics is logic. So in any case, consciousness, our reality is built of consciousness and evolution. Those are the two things, the two fundamental things. Okay, and those things are then repeated at different levels and scales. It grows, it builds, it creates, and you end up then with things like virtual reality. Well, that's just another iteration, you see. Now you have virtual reality, and this virtual reality is a creation so that consciousness can evolve. So we have another process that's evolving to help consciousness in a process that's evolving that ends up creating humans who create virtual realities, which is part of a process, that's evolving. And one day those virtual realities will spawn conscious, you'll have conscious computers and then conscious entities within a computer. And then what might they do? Well, they might create computers. You know, you see how it just goes on. It's a fractal process, but it's not a geometric fractal. It's a consciousness evolution fractal. But because evolution is not a geometry, it's a process, and I call it a process fractal. So that's, and you can see that how our reality often breaks down into pieces that represent each other. You know, we look at, you know, everywhere we see kind of similar things. We see information, and we see evolution. Well, consciousness is information, right? You see DNA, you know, and you see DNA evolving. And what is DNA? It's information. That's all it is. You know, it's a code, right? It's information, and it's evolving. So that's what our world's made of, is consciousness and evolution in this process fractal. Now, there are other process fractals that this is not the only one. I created the idea and I coined the word. So you won't, if you search on process fractal, you won't find anything unless you end up something about my book, because I created that word. But there are other process fractals that aren't called that. Some people have done, they're more like sociology experiments. These are very crude process fractals. But what they've done is they're very akin to what's called cellular automata. They'll take a big grid and they'll say, okay, all of these squares, we'll make all those squares black and all these squares white. And we'll have certain rules. We'll say that the colored squares like to stay around their own color. Black squares like to be located around black squares. White squares like to be located around white squares. But there's certain advantages of them intermixing, so on. So they make a couple of these rules, and then they take these squares and they'll put them in some configurations, like all the black ones in this corner and all the white ones in this corner, and then they'll say, run, go with the rules, because there's some rule about motion. You know, they're moving, they're doing things, and then they interact. And how do they interact? And the way they interact then becomes a model of racial integration. You see, black and white. And they've done these kinds of experiments. These are like sociology experiments. And they'll set them up and they'll start them all integrated. And they'll say, okay, all the black and white squares are all evenly mixed. And then they run. And they have these assumptions about, you know, they're more comfortable within their own, or there's more synergy, or there's more creativity if they mix. And they'll make certain assumptions. They try to keep it simple. And then they push the button and see what happens. What do they do? And then they'll change the assumptions and say, well, let's say they're not more comfortable within their thing. What's this? And then see what they do. So what they're trying to do is learn what are the dynamics, what are the sociological dynamics that affect integration. You see? So they're looking at all these assumptions and see how that affects the integration of these pieces. That's a process fractal. The processes that they're defining are these rules, these assumptions. It's a process. It's a little process that says, you know, if you're closer to someone of your own color, then you get an extra 10% in points for comfort. See, and that's kind of, so then you move this way for that comfort, but then if you're next to the opposite color, then you get certain points for maybe innovation, or for sharing, or you're getting new ideas. So you get points for that. And if this, you get points for that. So they're looking at all the ways that races can interact with each other, being helpful to each other, encouraging each other, or annoying each other, or scaring each other, and they try to put this in these simple things. Well, this is a process fractal. And I've seen it done with migrations. They do the same thing, trying to understand how was it that the people migrated across the Bering Strait into the Americas. And, why would they do that? So they come up with ideas of, well, this would be a better climate, so that's positive. They'll move this direction. This is harsh, so that's a negative. They won't move this direction. There's some advantage in being in numbers. There's some advantage, based. So they do all these things, and then they watch and see how it works. And if they can see what assumptions affect how the things move. So, so the social sciences have been using process fractals to test assumptions about how things interact with each other. And, that's been going on for some years. They don't call it a process fractal, but it really is. The processes are, again, are all their little rules, all their little assumptions about how things work, sets up a process. If this happens, then this happens, and they keep scores, and they move around according to the score. So a process fractal is, I coined the word, I came up with the idea, and I wrote it out. I later found out about sociology and anthropology and others using process fractals. And I thought, well, that's neat, that's really what they're doing. And this process fractal that creates, all of this reality, obviously is a much more complex with a much more complicated rule set. We've got a very detailed and complex physics, if you want, for a rule set. So we get more complex and more detailed things out. It's the same with the geometric fractals. So if a process fractal defines this reality, and this reality is basically consciousness, the medium, evolution, the process, okay, then if you look at process fractals, you start seeing things that start to look like consciousness, start to look like worlds. Well, that's what they're doing. They're sociology and anthropology. These things look like consciousness and worlds, right? Things are moving around for reasons. And they're aggregating or dispersing or doing whatever they do for sort of reasons. It sort of mimics worlds. Okay, well now you take a place that is 3D. Okay, our virtual reality is just a 3D geometric reality. Well, then if you take geometric fractals, you would expect them to start to look like a 3D reality. And that's what you get. So that's another big question of why do geometric fractals look like natural things? Why is it you take a fractal and it turns out to look like a flower or a seashell or the mountains? Well, the answer to that is this is a geometric reality. This is a 3D geometry-based reality. So your geometry-based fractals are going to look like it. That's just, it's just a natural outcome. So that's another one of those big questions that nobody knows the answer to and why that works. Sure, geometric fractals will mimic a geometrical reality because that's how the reality is put together.
You have discussed before and discovered other physical matter realities in your big toe. Should we be more able to discover things about the larger consciousness system from our particular reality?
Yeah, we are consciousness. So we have to stop thinking ourselves as a physical body in a reality, or even in a virtual reality, being a virtual body. We have to think of ourselves as consciousness. Being consciousness, we are part of the larger system. We're not just limited to this reality. Now there is I guess I should break this into two pieces. We have consciousness, the larger system. We have consciousness, a piece of that larger system, which is now we call a separate entity, but it's really just a piece of that system. It's just bubbled up, it's just a subset, like a subset of memory in a computer, right? You put in a little, a sector, it's not the word. Partition, that's the word I'm looking for. Yes, thank you, Zena, partition. So you partition off a piece of memory, and you say, well, now that's a separate piece of memory, but it's really still part of the computer. It's not like it's a separate thing by itself. It's just, you just put a kind of an imaginary boundary around it, right? And you say, here's the memory that we're going to use for this thing. So, but it's really still a piece of the computer's memory. Well, that's like us. Okay, so now we have the whole thing. That's the whole computer and all of the information field. And then we have a piece of that we partition off, and we say, all right, that's an individuated unit of consciousness. But we don't think that now that's a separate thing that's different than the computer. It's really just a computer, you see. And now that individuated unit of consciousness says, I'm going to take a part of my partitioned off space, and I'm going to take that part, and I'm going to let that part only experience within the constraints of this virtual reality, which is basically a defined set of constraints. It's an evolved virtual reality. It's a simulation from a digital Big Bang. Okay, so now I'm going to let a piece, and we call that the free will awareness unit. Okay, because that's then our local awareness in this virtual reality. As we sit and we're talking, we have local awareness. You know, we see the furniture in the room and the cameras and everything. We have an awareness of this. It's our local awareness. Well, that's our free will awareness unit. We have free will. We can make decisions. We're a player now in this virtual reality. Well, there is a individuated unit of consciousness of which we are a part. That's another partition inside the partition, if you will. But our free will awareness unit is that partition in the individuated unit of consciousness, which is a partition in the whole consciousness thing. But still, we're all just part of that computer. We're not different. Okay, and again, different scales, different levels. We have consciousness, and we have it. Still, it's evolving. The big thing's evolving. The individuated unit, which is that partition, is evolving. Then the subset. Here we are with the free will awareness units. We're evolving. See, it's part of the fractal process. You see one, and then you get the next scale and the next scale. So here, this free will awareness unit now is a piece of that individuated unit of consciousness that is limited, is constrained to only experience what the computer says this virtual reality can do. So now you're like the guy in the World of Warcraft. You can only do what the server in the World of Warcraft says you can do. If there's a mountain in the scene in the World of Warcraft and you're in there, you have to climb it if you want to get across it. You know, if there's a river, you'll get wet. You know, you have to only do, if your character can't jump 100 feet in the air, can't fly, well, too bad. Those are the rules in that reality. You have to run or walk or, you know, take a bus. You have to do something else. So you have to abide by the rules of the rule set. So here we are in this free will awareness unit. We have to abide by the rules in the server, in this virtual reality game that we're in. Okay, so so we kind of have levels. You see that we've kind of come down fractal levels down into this. Now, we are consciousness. Even this free will awareness unit is still consciousness. It's a subset of this, which is a subset of that. We're still part of the big computer. We're still just part of that mainframe. And as part of that mainframe, we can interact. We can gather other information. We have access to the rest of the mainframe. Okay, our access isn't shut off. For our consciousness, for our actions, for what we do here, we can only go as far as the rule set lets us go. But we're still consciousness. We're still a part of the big computer. You see, it's not like we've been chopped out of the computer and set off, you know, on a rock someplace, separate from the computer. We're still just a piece of that computer, so we still have access to the whole thing. We're still consciousness. So this free will awareness unit interacts here, abides by the rule set, drops things, they fall down, like the rule set says, but it's still part of the consciousness. It's still part of the big one consciousness. So it still can get around, if you say. It can escape this. It's limited here, but when it's not involved here, when it's sitting in a chair, meditating with its eyes shut, and it's only consciousness now, it's not acting here, then it can roam the larger consciousness system. It's got the whole server to run around in. So consciousness anywhere is like that. Any consciousness in any virtual reality can basically, you know, wander around in the larger system. The larger system's open to, you know, to all of it.
Thank you. Can we go back to the double slit experiment? I know you gave us a more detailed explanation than is out there currently. Could you now go into the importance of the double slit experiment to consciousness? Because there are many people out there who would say, well, you know, I don't really relate to this. I don't know about all this physics and the double slit experiment. What is that? You know, I'm not sure I could grasp that. And what does that have to do with me?
Okay, what that has to do with consciousness is that, you know, people tend to make something out of it that it isn't. They say, well, that shows that consciousness creates reality, right? Because consciousness makes the particle turn into a particle, but that's not really the case. You can say consciousness creates reality. Yes, of course it does. Consciousness is the one fundamental thing. Everything else is a creation, if you will, a virtual creation of consciousness. So yeah, that's sort of true, but that's that's a misrepresentation of the double slit. The way the connection works is that what the double slit experiment tells you is that reality is not a objective reality, that reality is statistical and informational and probabilistic. Information's the key, so it tells you information's important. It says that it's probabilistic. The particles aren't really particles, they're probability distributions. So it's telling you that fundamentally we have a reality where things exist in probability. That doesn't follow an objective causality. Objective causality is just an approximation. It doesn't follow that. So once you've done that, then it's easy. That's telling you that this physical world is not fundamental. It's not the base. You see, when you believe this is the base, then you do silly things like thinking that your brain creates consciousness, because everything has to be derived out of the base. You see, so it tells you that's not the base. Physical reality isn't fundamental. It has to be derived from elsewhere. And this elsewhere, what is it? Oh, it's probability and it's information. So it's telling us that what's more fundamental than physical reality is a information field that's largely based on probability. Okay, so it gives us that. Then then we get to the question that of course Fredkin had. Well, if that's the case, where is this? And who programmed it? And da-da-da-da-da. And the answer is other. Well, it seems clear then that other is consciousness. So the double slit experiment is basically opening up our eyes to a larger reality, tells us something about that reality. It's information-based and probability-based. And then it's not a great leap, because we do have consciousness. We are conscious, to say that consciousness is the computer. So in that way, you kind of have the idea that the double slit kind of leads us to consciousness. But that's the way it leads us to consciousness. Not some magic thing that our consciousness creates the reality. The larger consciousness system creates all virtual realities. And an interesting thing about virtual realities is a virtual reality is required for experience. If you're just in the larger conscious system, not in a virtual reality, it's just information. Okay? If you want to have an experience, if you want to interact with an experience, you need a virtual reality. If you have a virtual reality and you're going to interact, you need to have choice, so that you have choices of how you interact. So it's in the virtual realities that you have free will. So here you are, and you're an actor, you have free will, and you're in a virtual reality. So let's say you die, and you're gone now, you're not in this virtual reality, and let's say you're not in any virtual reality. What are you? You've not gotten into any virtual reality. You're not in the out-of-body reality, you're not in the dream reality, you're not in any virtual reality. Well, then what are you? You're a data set in the computer. You're in the big mainframe. You're in the larger consciousness system, and you're just a data set. Do you have free will? No. Are you interacting? No. You're just a data set. Now, because the larger conscious system wants to evolve, and it uses these individual units to evolve, and you're a good player because you work hard and try to grow up and raise the quality of your consciousness, it says, oh, I'll take this data set called Donna, and I'm going to play her in this game because she's a good player. It's like, oh, I really like my dark elf here, and I like my barbarian, and I'm going to play them in this game because they're good. I'm not going to play my lizard man because I never get anywhere with him. He just always gets creamed, and I lose points instead of gaining points. So the lizard man's out. So they go up and they get Donna and they play her in this reality and say, okay, go Donna, go learn, go evolve, help me out here. So now you get put in a virtual reality and you get free will. Otherwise, you're just a data set. So when we are engaged in a virtual reality of some sort, we have choices, we have free will, we're interactive, we grow up. Otherwise, we're just potential beings, if you will, potential characters without free will. But now that data set's very complete. That has all of our history, everything we've done, all of the lives we've been through, everything we've learned. You get the whole accumulation of who and what we are with everything we've done, thought, been, felt, seen. All of the characters and all the lives is all kind of is in that data set. And then we get played as there's room, as there's need, and as we function.
Thank you. That leads into the next question, really, because we hear a lot these days about how helpful past life regression is. Some people just spontaneously recall past lives. But from your scientific viewpoint, you call it a database. There's a future probable database, an actualized past, and an unactualized past. You have said before that you can query a historical character and get an answer, and that is similar to what people do with the Akashic records, but this is simply from your scientific viewpoint. Are those models of these scientific characters, are they limited to what they thought and accomplished in their time, or could they discover anything new and answer a question that was outside of what they knew at the time in their lives?
No, they have no free will. Okay, they're just data. They're just information. It's just a historical record. It's like going into a really cool library where there's not only books, but you have this multimedia, holographic, 3D figures that talk, and it's that kind of a library. It's a library that's not just linear on pages, but it's a 3D experience. But it's just a library. It's just information. There's no free will. There's no ability to do something new, to come up with another discovery or anything like that. So those databases are, let's say you in that database. Let's look at your history. Go to your historical, go to one of your past lives. So you go and you interact with that past life, and you can ask it questions. You can get information, and everything that it knew, experienced, felt, thought, whatever is available to you. But if you go there and present yourself in exactly the same way and ask exactly the same questions, which means you input exactly the same input, you will get exactly the same response. Now, that's if your intent is to get the most likely response. But you could intend to say, well, I don't want the most likely response. I'd like to get, because it's all there. Everything that happened, didn't happen, you're all there with all the probability. You can go other lanes of not the most probable response. But even if you do that, say, well, okay, I want to get the third most probable response. And every time you do that, you always get the same. The third most probable response will always be the same. So there is no creativity in there. There is no free will. It's just data in the database. Now, why is that helpful to go back there? Well, we said that you are an accumulation of all these experiences, all these lifetimes. You are an accumulation. Now, some of those lifetimes, you had fear, you had all kinds of things, right? That's what we do. We deal with whatever happens to us, and then we grow from it. And then we're the accumulation of all the stuff that created. Well, let's say you had some particular traumatic experience in one of those lifetimes. Well, it's cumulative. That result that it had on the quality of our consciousness, so that trauma is still there because it's cumulative. It's not like, well, we just keep the stuff we like and we throw the rest away. It's our cumulative experience. So now we have that issue there. So we can now work on that issue. So maybe our issue is fear. Maybe our issue is anger management. Maybe our issue is that we're afraid of mice. I don't know, something, and it just hits us that way. So it could have been because the reason that issue exists is some thing that had happened in some previous life may have accumulated up to that. That problem is there because of that. And if you can solve that problem now, good. You grow up, you get rid of the problem. So if you can not be afraid of mice, you may fix that problem, and other reincarnations won't have that issue. And one way to do that is this regression thing. And you go back, and if there's something, because every time you see or hear, you see a picture of a mouse, you scream. And it's embarrassing because it's stupid, right? You feel like that's really, this is really dumb of me. But if I walk in some place and somebody's got a cat and a mouse picture on the wall, I'll scream because I have this thing and I can't help it. What's wrong with me? shrink, you go to the shrink, and the shrink says, well, we'll do some past life regressions and see if we can find out what has happened. And then you go back and you found out that, 10 lifetimes ago, you were attacked by an 8-foot mouse that, who knows? You had to eat mice because that's all there were, and you ate them for 6 months, and you finally died eating mice or something, and you have this aversion to mice. Who knows what it is? But what it does is it brings up the problem. Now you've identified it. You've made it seem more real because you said, oh, it's because I was attacked by a big mouse. That's it. Okay, well, that's not so bad. That was a long time ago. I can get over that. So it gives you some encouragement, puts you in a frame of mind that you can deal with it, and helps you then deal with it. So that's the point. It's like, anytime, if you can name something and give it a form and a face and a figure, it's easier to deal with than when it's just this problem. So the past life regression does that. It can make it more real, which then makes it easier for somebody to deal with it. It doesn't really change anything. It's just a tool that you can use to help focus your attention on growing out of some particular issue that you've got. So that's how that works.
Thank you. That also leads into another question. Do we return, because we recall all of these things, we are cumulative experience, do we return with our full cumulative experience, with our full quality of being to this present incarnation?
Yeah, we do. We come in, we have to now kind of define two levels of awareness. We have an intellectual level of awareness. That's just what that's kind of our local awareness. It's what's in our intellect. It's what we know about. But besides that, we have another level that I call our awareness at the being level. We exist at both levels. The being level is my way of saying that's what we really are at the core. That's us. That's not our intellectual view. We can know something intellectually, but not know it at the being level. We can get over a fear intellectually and say, well, I'm not going to be afraid of that mouse. I'm going to do this, I'm going to do that. And we can kind of force ourselves to do it. We can play. We can act. Oh, I'm not going to get angry. I'm going to go around and kiss every baby I see, and people will think I'm sweet and whatever. From the intellect, we can do things like that, but it doesn't mean that it's real. It's not coming out of the core of us. It's not coming at the being level. It's not genuine. It's our intellect controlling our behavior. Okay, so that's the difference between your intellectual level and the level at the being level.
Well, thank you. That just answered. Then the next question was, there is thought outside the intellect. You commented on in a meditation state doesn't mean that you are floating without any control of your thought. Can we be more intelligent and less restricted in this state and solve problems?
Yes. It's a real good point. People get very confused about that because I tell people, if you're going to go to the point consciousness state, and in a point consciousness state, tell your intellect to be quiet. We don't want any intellect there, and the reason we don't want intellect there is the intellect is the operative part. It's the part that's grinding. It's doing analysis. It's judging. It's comparing. Is this good? Am I in the right state? How does this feel? It keeps gnawing at the problem. That's what your intellect does. Okay, you want to let go of all of that. All you want to do is just exist. No intellect. Get rid of it. Just exist. And when I tell people that, they get confused because they say, well, if the intellect's gone, I don't exist because I am the intellect. That's me. You see, I'm this awareness with my intellect, and if I take that and throw it away, who am I? What am I? I'm not, I don't even exist anymore. Well, it's not true. You do exist. You exist at the being level. It's not your intellect. At the being level, you can be aware. I tell you the difference. Descartes said, I think, therefore I am, or something like that. People are arguing over actually the translation of what he said, but I think, therefore I am, okay? In his statement, I am, is not a statement of ego. I think, therefore I am. It's not a statement of ego at all. That I in the I am is not his intellect. It's not I think, therefore, I'm this intellect. It's I think, therefore I exist. That's at the being level. That's the I am at the being level. Okay, now, I am sitting in this room on a chair and there are lights and those are cameras and da 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 da, and I think this is a lot of fun or whatever. That's me at the intellectual level, not at the being level. That's not the I am of I exist. That's the I am of me here interacting with this. See, there's a difference. And that's what I'm differentiating between the intellectual level and the being level. So you go to point consciousness where you turn the intellect off. No jabbering, no analysis, no judgment. It's not about how am I doing. You know, it's none of that. It's just I exist. It's the I am of I exist. I think, therefore I am. And there you are. You just exist. But that same existence can also give direction. It can also, okay, here I am. I'm floating in the void, just a point of consciousness, and all I'm really aware of now is that I exist. But I can still think. It's not just the intellect that thinks. You can still think just as a being that's existing. But now you don't want to start operating. You don't want to, you don't want your thoughts to start operating. You don't want to start judging, to start analyzing, to start second guessing. That's the intellect. You see, I'm trying to make a difference here. It's a little subtle to see the difference, but that's the difference. So it's just I am, and I would like to visit such and such a place. Now I would like to heal so-and-so a person. And I'd like to see, all of their problems in dark and their good stuff in light, and, so on. You can do that. All that direction can come from the being level, not from the intellectual level. So that the being level, you can have awareness, and you can even think. You can direct, but you're basically in total acceptance of whatever. You're not judging, you're not comparing, you're not doing any of that stuff that the intellect does. You're just being. So you do have thoughts. You can think. You can direct. But you can't manipulate. The language is hard. I'm saying this kind of over and over in a lot of ways to try to get at a point, but there's a difference between operating out of the being level and operating out of the intellect. One of the reasons that we have two learning labs in which we grow up in, one that's physical and one dreaming, is because in this physical reality, we tend to operate with our intellects. Our intellects dominate. And we do everything in intellect. Well, when your intellect dominates, it's real easy to kid yourself. Oh, I'm a really nice guy. I don't have any fears. I don't have any ego. I'm there already. I don't know why I can't do these things or whatever. We can kid ourselves. We believe all sorts of things that aren't true because our ego, wants us to believe these things. It makes us feel better to believe these things. When you dream, that intellect is not operative. It's like that intellect, it's off. When you dream, you tend to be an actor at the being level. So here, you're the bravest person around. There, you scream and run, you see, because it frightens you. Or, it's that kind of thing. So the way we learn in the dream reality, one of the advantages of the dream reality, so that we can learn, is that we interact in how we are. What you get is what you are out there in the dream reality. And if you're a kind of person who gets angry, things happen out there in your dream and you get angry, you get upset, you get this and that in your dream. Whereas here, the same things might happen. You may suppress that anger. You're not going to get angry because that would be foolish. Everybody would look at you and think, look how angry she's out of control. In your dream, you can't help it. You just are. You're fearful, you're angry, you're this, you're that, you're hurt. You're scared. So that's one of the big advantages of the dream reality. And in the dream reality, you can function, you can think, you can do things, but you just are who you are. You don't have all these layers of acting superimposed over it, and that's what I'm calling the intellect. So I'm probably, creating words here, right? I'm saying intellect and being level, and I'm kind of defining them in a special way that isn't necessarily used by everybody, but I'm trying to make it clear, what I mean when I say those words.
I think that's going to be very helpful to people. Tom, thank you for this interview today.